welcome. Now we want to find the solution to the congruency equation. X to the power of 103 congruent to 11 mod 11. Congruent to 4 mod 11. So what we can see here is this is a prime number. This is a prime number. But no information is given about x. So we cannot assume that x does not divide 11, or rather 11 does not divide x. If that is not there, we can use the Fermat theorem that says a to the power of p is congruent to a in mod p. So in this case, that means x to the power of 11 is congruent to x in mod 11. But we have x to the power of, we've got x to the power of 103. So we can raise this to at least get to 103. And how do we do that? It is clear that this is 11 to the power of, this is to the power of 9. Both sides to the power of 9 in mod 11. That is x to the power of 99, which is now congruent to x to the power of 9 in mod 11. To get x to the power of 103, I'll need to just put 4 both sides. That means I'm putting a 4 here as well. And I'll have mod 11. So that actually tells us that x to the power of 103 is congruent to x to the power of 13 in mod 11. Right? But if you check from the start, we had a statement that says x to the power of 11 is congruent to x. That's what we said in the same mod 11. That's what we used. So because we have got that now, means we can also further use it here by saying x to the power of 11 to the power of 2. I've just disintegrated 13 in that. But because I want to substitute x to the power of 11 with x there, I'm going to have this equivalent to x to the power of 3 in mod 11, because x power of 11 is the same as your x there. So as a result, this implies that x to the power of 3 is actually congruent to 4 in mod 11 from the start of the statement. It's actually congruent to 4 in mod 11. So if x is congruent to 4 in mod 11, I think we can now do inspection here to find the value of x. Because if you want to think of a number that gives you a remainder of 11, a remainder of 4, when you divide it with 11, that number has to be a cube. Certainly you can't start with a 2 because 2 is 8, you can't divide that. 3 is 27. How many 27s are 20? How many 11s are in 27s? There are 2 of them. That's 22 with the remainder of 5. So that's not working. We can think of another number, 4 to the power of 3. That's 4 times 4. That's 16. 64. How many 64s? How many 11s are in 64s? I mean, you can say 11 times 5, that's 55. 11 times 6, that's 55. To get to 64, we still don't have a remainder of 4. We can think of 5. 5 squared is 125. How many 25s are in 11? So I can say 11 times 11 is 121. What about 11 times 12? 11 times 12 is going to be 1. Because we've got 5, I can think of a number, 5 to the power of 3, that's 125. 11 times 11 is equal to 121. Yeah, that works very well. So if we divide, if we use 5, we are going to get 125 here, and 125 mod 11 is congruent to 4. So therefore, by by inspection x is equal to 5. That's our answer. X is equal